Okay, this is the lesson for 3.3. I had a little bit of an issue with the sound, so I'm just going to have to do a little voiceover onto it. Okay, this is a section on completing the square. And so you may have noticed in 3.2, when you have a quadratic function in standard form, it's not necessarily as useful as when you have it in this vertex form that I've just drawn in this box. Okay, in the vertex form, you can find the coordinates of the vertex. You have A that gives you the shape of the graph. Okay, in standard form, A tells you the shape of the graph. C tells you the y-intercept, so fairly useful, but I would say that knowing the vertex is a little more useful than that. So what we're going to learn is a fairly straightforward process when you're given a standard form quadratic equation to convert it to vertex form. Okay, we know it's easy to convert the other way. All you need to do is square that binomial. Okay, use FOIL to square the binomial, distribute the A, and group your like terms, right? But it's a little bit of a different technique to go from standard form to vertex form. Okay, so we're going to learn that today. Okay, and one thing I just underlined that's a binomial squared, and you may remember from Foundations 10, Foundations in Pre-Calculus 10, what it looks like when you square a binomial, okay, or how you can recognize a trinomial that could be factored as a binomial squared. Okay, so that's what we're going to do right here. Okay, and this is a technique, it's called completing the square. And so basically what it is you have the first two terms of that trinomial that can be written as a binomial squared, and you need to find the last term, that's the constant term, that makes it into a perfect square. Okay, so you may recognize x squared plus 2x as the first two terms of a trinomial. Trinomial that was a square. You probably don't, so I'm writing it on the right. And maybe you remember this one. We looked at these. They're special because the first term is a perfect square and the last term is a perfect square, okay? And the middle term is 2 times the product of those two square roots, okay? So if the square root of the first term is x and the square root of the last term is 1, okay, then you have 2 times 1 times x, and that's your middle term. Okay, and then I wrote up on top there the factoring of it. X, that's the square root of the first. 1 is the square root of the last, okay? And so x plus 1 squared is the factoring of this trinomial square, okay? Going back to the two terms that I have there on the left, x squared plus 2x. You want to find that last term, you can take the 2. Okay, we know that x is the square root of x squared. Okay, so that 2 is 2 times the square root of the last term. Okay, so it's 2 times 1, so 1 must be the square root of the last term. So that's why our last term is 1. Okay, simple technique, x squared plus 4x. Take that 4, divide it in half, that gives you 2, and then square that. So 2 squared is 4. That means we're going to add a 4 on the end here. See, I put a 2, I'm going to fix it. Okay. Add that 4 on the end. That's a perfect square right there. Okay, and we'll factor that in a second, okay, because you have perfect square on both ends, x squared and 4. Then you take those two square roots, x and 2, multiply it by 2 to get your middle term. Okay, that middle term is 2 times x. Okay, here's another one. Again, simple technique. Okay, take the coefficient of that x, that's 8, divide it in half to get 4, and square the 4 to get your last term. Okay, notice that middle term is 2 times x times 4. Okay, what does the factoring look like? Well, it's just the square root of the first term plus or minus the square root of the last term, and then squared. Okay, how do you know if it's plus or minus? You look at the sign of the x term. Okay. In this case, we're going to have a negative. When you take half of that, you get a negative 1, which you square to get a positive 1. So completing the square, you still get a positive third term. But what that does for you is that it makes it x minus 1 squared instead of x plus 1. Okay. For this one, divide that by 2, get negative 3. Square that, you get 9, but it's x minus 3 squared. And if you can follow that, you're going to have no difficulty changing from standard form quadratic equations to vertex form. Okay, it's just a little bit different. Just basically, there's one more thing that you have to take into account, and we're going to see that on this next page. This is an example of a standard form quadratic equation. Okay, this is a fairly easy one because it has a 1 in front of the x squared. What we want to do, we notice that that's not a perfect square because that 5 is not a perfect square. So we're going to move the 5 over, forget about it for a second, and put what we can onto the end of that to make it a perfect square. So take the -8, divide by 2, that gives you -4, and then you square the -4 to get 16. Okay, so what we're going to do is we're going to add the 16 onto there so that we have a trinomial square. Okay, now I don't want to change my function by adding 16, so what I'm going to do is I'm going to immediately subtract 16, and what that does, I basically added 0 overall, so I haven't changed it. Okay, but this is going to allow me to group things a little differently. If I take that trinomial square, those first 3 terms, I can rewrite that as x minus 4 squared. Okay, I'm going to group those last 2 terms, and I can rewrite that as minus 11. And what I have now is a vertex form equation. Okay, between my 2 equations, I have a lot of information here. I know that my vertex has an x coordinate of 4 and a y coordinate of -11. I know that my a value is a +1, so it's going to open up, and it's going to be a sort of normal width. Okay, and I know from the top, from my initial equation, that I'm going to have a y-intercept of 5. Okay, so I actually have quite a lot of information that I could use to graph this. Okay, and that's basically the end of the lesson.